Hello, my name is Nastasia Masalova. This is my lab report on the topic of the oscillations. The main goal for the first lab is to analyze the movement of an oscillating spring and forces acting on the system, as well as implement energy principle to find energies that exist in the system. This experiment is important for us because it helps to understand how many mechanisms work in engineering, for example, car suspensions. Additionally, this experiment allows us to implement knowledge of physical concepts covered in the course to solve a real-life problem. Before I elaborate on the lab and the results, I want to cover several concepts and formulas that we will need for analyzing the motion. To predict the ball's motion, we need to know the net force acting on it. There are two forces acting on the ball, the force of a spring and the force of the gravity. The force of gravity is gravitational constant multiplied by mass. The spring force can be found by the formula minus coefficient of stiffness multiplied by change in length of a spring. Knowing the net force, we can implement velocity update and position update formulas by creating a computational model. Additionally, we will need to implement energy principle for a system of a spring, ball, and earth and no surroundings. Since there is no force acting on the system, the work will be zero, and the change in energy will be zero. There are three components of energies that we will need to consider. The first one is the kinetic energy, which equals to 1/2 mass multiplied by the velocity squared. Another one is the gravitational potential, which near the surface of Earth equals to mass multiplied by the gravitational constant and height. The last energy is the spring potential energy, which equals to 1/2 spring stiffness multiplied by the difference of the length of the observed spring and its relaxed length. To get data about the object position in the video, I use a tracker application to analyze motion. I created around 80 points to track the object's X and Y components. To complete the next part of the experiment, I had to modify several lines in the glow script starter code. First, I changed the physical characteristics of the system, such as the ball mass, spring stiffness, and relaxed length of a spring, which I took from the lecture number 53. After that, I added the formula of a spring length L, which equals to ball position minus spring position, and made L hat equal to L over magnitude of L. I also introduced a new variable S, which equals to L minus L0, where L0 is the relaxed length of a spring. Finally, I used the formulas I discussed before to calculate energies of the system. After the initial changes, I modified several lines in the while loop. Specifically, I changed the value of a spring and gravitational forces and calculated the net force. I also used the position update formula and velocity update formula to get the position and velocity of a ball on each iteration. Since the spring force is non-constant, I also had to update L, L hat, and S. Finally, I also found the values of each energy and change in energy on each iteration. After modifying code in glow script, I ran the program and observed the motion of the ball on the spring. After running the program, we received the three graphs. The first two graphs show the relationship between X and Y components of the model ball and the experiment ball. We can see that there is a slight difference between the two curves on each graph. This difference occurs because we don't consider the drag force in the computational model. In reality, however, the drag force acts on the system and opposes the direction of motion, so the magnitude of position of the computational model is greater than the one in the experiment. On the second graph, we can observe the change in energy of the system. Since there was no surrounding force, delta E was always equal to 0, but other energies changed. After conducting the experiment, I needed to give answers to two questions. The first of them asks if the energy principle is satisfied in the experiment. The answer is yes. In the experiment, we decided to take the ball, spring, and earth as a system and consider that there is no surroundings. For the energy principle, the change in energy should be 0. And as we can see from the graph, the change in energy was 0. This means that the energy principle is satisfied. The second question was to discuss the difference of periods in oscillations on all X and all Y axes. With the obtained data from tracker, I found a period in both cases, and these periods are the same, approximately 1.519 seconds. This result shows that there was little observation error in my experiment because the period of oscillation should have been the same no matter what axis we chose. Thank you so much for watching my video. Hope to see you in my future labs.